Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today I am going to discuss some of the problems based on the line integral. So in the previous video we discussed about what is the line integral, what are the formulas we can use to calculate the line integral, and what are the applications for the line integral we discussed. So today I am going to discuss some of the problems based on the line integral, how we can calculate that line integral by using those formulas. So we can observe here about the line integral of a scalar field. So here we are taking the scalar field f equal to f of r over the curve C, and here we can calculate that line integral over the curve C by using this formula, that is integral over C f of r ds. And here this is the line integral of vector field. So here we can calculate line integral for the scalar field and the vector field also. So for the scalar field we are using the formula integral over C f of r ds, and for the vector field we can observe here integral over C f of r ds. So then that function is vector. So if it is the curve parameterized by the function r equal to r of t from the a to b, then we can calculate the integral like this by using the same integral over c f of r dr. So here we are going to replace the r of t and limits are from a to b. So f of r of t equal to dr by dt. So in place of dr we are writing dr by dt into dt. Then there will be no change in the value. So here finally this is, we can write r dash of t is nothing but dr by dt. So now finally the formula is integral of a to b f of r of t into r dash of t into dt. So here the work done, we can observe F represents the force acting on the particle moving along the arc AB. Then the total work done we can calculate here by using the formula. So W equal to integral a to b f dot dr. So one of the most important physical application of line integral is that to finding the work done on an object moving in a force field. Here we are discussing the examples to understand about the work done, how we can calculate the total work done by using the formulas for the line integral. So here see the question, find the work done by the force field. Find the work done for the force field. What is the force field they given? F bar of x comma y comma z equal to minus 1 by 2 into xi minus 1 by 2 into yj plus 1 by 4 into k. 1 by 4 into k. On a particle as it moves along the helix given by r of t. What is the helix here they given? R of t equal to cos t into I plus sin t into j plus t into k. So here helix is given, that is r of t, and f is given here. This is the force field. So here this r of t from the point 1, 0, 0 to minus 1, 0, 3 pi. First of all, we are going to calculate the integral f dot dr. So in this one, what is the f dot dr? First we have to calculate, right? So first of all, we are writing the f and r. See here, f is here given force field, f equal to minus 1 by 2 into xi minus 1 by 2 yj plus 1 by 4 k. And r of t is given cos t into I plus sin t into j plus t into k. Now here we can observe r already we know that this is xi plus yj plus zk. So when you are comparing this one with this xi, yj plus zk, we can write this x of t equal to cos t, y of t equal to sin t, and z of t equal to t. So we can observe here, in place of x we are having cos t, in place of y we are having sin t, in place of z we are having t. So that we can write x of t equal to cos t, y of t equal to sin t, and z of t equal to t. Thus, the given force field can be written as, here we are writing the force field by using that form. So, f of x of t comma y of t comma z of t. Actually, we are writing this one as f of x comma y comma z. Thus, but these terms are in terms of t. These are in terms of t now. So, here we can write f of x comma t. In place of that, we are writing f of x of t comma y of t comma z of t. That value is 1 by 2 into cos t into I minus 1 by 2 into sin 2 into j plus 1 by 4 into k. So here first we are calculating the first derivative. So based on the first derivative, what is the first derivative for after of t is cos t into I plus sin t into j plus t into k. That is only we can observe here, are equal to cos t into I, sin t into j plus t into k. So here r of t equal to cos t into I plus sin t into j plus dk. So we are writing, or we are calculating the first derivative of r of t. So cos t, here derivative of cos t is minus sin t. This is the derivation formula, I into I plus derivative of sin t is cos t. So cos t into j plus t is 1 into k. So here this value is first derivative of r dash of t. So now we are calculating the work done. Work done formula is integral over c f bar dot dr. So here f bar is we are taking as x of t comma y of t comma z of t dot dr bar. Dr bar here we are taking dr bar equal to r of t, r dash of t into dt. Already just now I told you in the formula, in place of dr, we are writing dr by dt into dt. So dr by dt is nothing but r dash of t. In the formula only we are having this one. So we are replacing here r dash of t into dt. Now see, here they given the terms. The points are from 1 comma 0 comma 0 to minus 1 comma 0 comma 3 pi. So first we are converting all these values into t. Then we are going to take the limits of t. So based on that we are taking the values here. Integral 0 to 3 pi. What is that value? So t terms. Here first f dash of r and f of x comma y comma t value. This is f of x of t comma y of t comma z of t. This value dot r dash of t into dt. So f of x of t comma y of t comma z of t value is minus 1 by 2 into cos t into I minus 1 by 2 into sin 2 into j plus 1 by 4 into k. So that one dot r dash of t is we got minus sin t into I plus cos t into j plus k. So now we are doing the dot product. So first one is I dot I is 1. So 1 by 2 into minus 1 by 2 into cos t, here sin minus. So here I coefficient and here also I coefficient. So I dot I is 1. So both values we are going to multiply, minus 1 by 2 into cos t into minus sin t I dot I. Coming to the second term. Here. So now coefficient of j, that is minus 1 by 2 into sin t into cos t. So j dot j is 1 plus 1 by 4 into 1. 1 by 4 into 1. Now finally 1 by 2 into sin t cos t. This value is minus and minus. Minus to minus is plus. So 1 by 2 into sin t cos t. Here plus into minus is minus. 1 by 2 into sin t cos t plus 1 by 4. So now from this integral 0 to 3 pi. So 1 by 2 take the common. 1 by 2 take the common here. So sin t cos t minus sin t cos t plus 1 by 4 into dt. So here these two values are cancelled. So first term is 0. So finally I am having the value integral 0 to 3 pi 1 by 4 dt. So 1 by 4 is the constant. Taking out integral 0 to 3 pi into dt. So integral dt, what is the value of integral dt? So integral dt is t. Limits are 0 to 3 pi. Limits are 0. That is only we wrote here. 1 by 4 into 0 to 3 pi. So 1 by 4 into this value is. So here 1 by 4 into upper limit, that is 3 pi minus 0. So finally 3 pi by 4. This is the final answer. This is the final answer. So what we have to do first, we have to calculate AR dot DR bar. After then we can integrate along curve C. Then this will be equal to the work done. So final work done W equal to, we got the value 3 pi by 4. 3 pi by 4. This is the way to calculate the given work done if they given the parameterized. Next, see the next question. Evaluate integral over C y cube dx. Y cube dx plus x cube plus 3xy square into dy, where C is a circle of a radius 3 given by R of t is 3 cos t into I plus 3 sin t into j. Now the t is in between 0 to 2 pi. Now first given what they given R of t equal to x of t into I plus y of t into j. So here what is that value that they given in the problem? 3 cos t into I plus 3 sin t into j. So what we have to calculate? Evaluate integral over c y cube into dx plus x cube plus 3xy square into dy. We have to calculate this value by using the given R of t. So now here when I am comparing this value, x of t equal to 3 cos t. So x of t equal to 3 cos t. So y of t equal to 3 sin t. So y of t equal to 3 sin t. Now I am going to calculate dx by dt. Why? Because I need to convert all terms in terms of t, right? So based on that, first I need to know this value. So dx by dt. So dx by dt is 3 is the constant. Derivative of cos t is minus sin t. So finally dx by dt is minus 3 sin t. And here dy by dt is 3 is the constant. Derivative of sin t is cos t. So dx equal to minus 3 sin t dt and dy equal to 3 cos t dt. Now I am going to calculate the integral here. Integral over c y cube into dx plus x cube plus 3xy square into dy. Now I am converting all these values in terms of t, and the given t limits are 0 less than t less than or equal to 2 pi. So that's why we are taking here integral 0 to 2 pi. Integral 0 to 2. What is the y cube? We can observe here. What is the y value? Y is 3 sin t. Y is 3 sin t. So here y cube equal to 3 sin t whole cube. So nothing but this value is 3 cube sin cube t. So this is 27 sin cube t. That is only we can observe here. So 27 sin cube t. Next dx. So here what is the dx value? So dx equal to minus 3 sin t dt, minus 3 sin t dt. So in place of dx, we replaced minus 3 sin t dt. Next, plus x cube. What is the x value here? We can observe x equal to 3 cos t. X equal to 3 cos t. So x cube equal to 3 cos t whole cube. 3 cos t whole cube. So 3 cube is nothing but 27 and this is cos cube t. So here we are writing in place of x cube, we are writing 27 cos cube t plus 3. Here 3 into x value is 3 cos t and y square. Y square is 9 sin square t. So here x equal to 3 cos t and y equal to 3 sin t and dx equal to and dy equal to, here dx equal to minus 3 sin t and dy equal to 3 cos t. These values we used here to convert all x and y terms in terms of t. After converting that, we should know about the t limits. Already in the question they given 0 less than or equal to t less than or equal to 2 pi. So based on that, we are replacing the values here. 0 less than t less than 2 pi. So integral 0 to 2 pi. Now we are going to simplify this. After that, we can do the integration here. So now we are simplifying this one. 27 into minus 3. So 27 3 is 81. So minus 81 sin cube t into sin t is sin power 40. This value is minus 81 into sin power 40. Now next 27 cos cube t and here 27 cos cube t, here plus 3. Here we can multiply this one with the cos. So 27 cos cube t into 3 cos t. 3 cos t. So now 27 into 3. 27 into 3 is 81. Cos cube t into cos t is cos power 40. Next term plus 3 3s are 9 here. 9 and one more 9 is 9 9s are 81. So 81. 3 cos t, here cos t. So 3 cos square t and sin square t. So here, if you want, I will give the simplification here. 3 into 3 cos t into 9 sin square t into 3 cos t into 3 cos t. Now 3 3s are 9. So 9 into 9 is 81. 81. So cos into cos. So cos into cos, that is 3 cos square t and here sin square t. This term only we wrote here. So finally we got here minus 81 sin power 40 plus 81 cos power 40 plus 81 into 3 cos square t sin square t dt. Now in the all terms we are having 81. So we are taking out. So 81 integral 0 to 2 pi. So here sin power 40 and here cos power 40. So if this is the plus value, we are writing first. So cos power 40 minus sin power 40 plus remaining here 3 cos square t sin t dt. Now I am writing this one as, this is in the form of a power 4 and b power 4. So I can write this one as a square minus b square form, that is a plus b into a minus b. So here a is a square minus b square is equal to a plus b into a minus b. What is the a here? A we are taking as cos square t and b we are taking as sin square t. B we are taking as sin square t. So 81. So here cos square t minus sin square t means a minus b into a plus b. Plus here 3 as sin square t cos square t. I am writing here with this 2 cos t sin t whole square. So you can write this one as, here I am multiplying with the 4 and divided by 4 here. So then this value becomes 2 cos t sin t whole square by 4. Now, why I am converting this one to get the integration and to can simplify it easily to integrate the function. So here cos square t minus sin square t. Here sin square t plus cos square t value is 1. So finally we got cos square t minus sin square t, and here 3 by 4 constant taking out 2 cos t sin t. So 2 cos t sin t. This is the trigonometric formula. We can write this one as a sin 2t. Sin 2t formula. This one sin 2t formula. Sin 2t equal to 2 sin t cos t. So now we are writing already 4 square is there. So sin square 2t. According to the formula, we are writing here. This one is sin square 2t. So now cos square t sin square t, and here we are simplifying this one according to the given. So cos square b minus sin square b, we are having the cos square 2t formula. So this one is cos square 2t and 3 by 4, and this one is sin square 2t. Now we are going to simplify this one to do the integration. Now this cos 2t plus 3 by 4, here I am writing this one 81 integral 0 to 2 by cos 2t plus 3 by 4 integral into this one is 1 minus cos 4t by 1 minus cos 4t by 2 into dt into dt. So now I am simplifying this one cos 2t as it is. 3 by 4 into t here. So we can write this one as 3 by 8 into 1 minus cos 4t into dt. Now we are simplifying this one 81 cos 2t as it is, and 3 by 8. Now we are doing 3 by 8 into 1 is 3 by 8. After that 3 by 8 into cos 4t dt. So now we are doing the integration here. Integral 0 to 2 by cos 2t dt separately individual terms. Integral 0 to 2 by 3 by 8 dt minus integral 0 to 2 by 3 by 8 cos 4t dt. Now here we are doing 81. Here integral cos 2t is nothing but sin 2t by 2. Sin 2t by 2 limits are 0 to 2 pi plus 3 by 8 is the constant. Integral dt is t, limits are 0 to 2 pi minus 3 by 8 is the constant. Integral cos 2t is nothing but sin 4t. Here cos 4t, integral cos 4t is nothing but sin 4t by 4. Sin 4t by 4. Integral cos is sin. Integral sin is minus cos. So here this value, the limits are 0 to 2 pi. Now we are simplifying here 81 into sin. They are replacing the limits now. 81 into sin. In place of t, we are replacing 2 pi, right? So this is sin 4t divided by 2. Next, and sin 0. We are also in place of this t, we are replacing 0. So sin 0 is 0. Next term, 3 by 8 into 2 pi minus 0. 2 pi minus 0. Here minus 3 by 8 into 4. For in the limits we are substituting here. 3 by 4 into 2 pi. So sin 8 pi. Sin 8 pi. Minus sin 0 is 0. Minus sin 0 is 0. Now 81 into sin 4 pi by 2 plus 0. 3 pi by 8. 3 by 8 into 2 pi. Here 3 by 8 into sin 8 by 0. So already we know some information, that is sin n pi is 0. So sin n pi is 0 means here sin 4 pi is 0 and sin 8 pi is 0. So this value is 0 and this value also 0. Now we are going to substitute here 81 into this term is 0. Next here 3 we are cancelling this one. So finally This one is 3 pi by 4. Second term is 3 pi by 4. So sine 8 pi also 0. So that term also 0. This is already completely 0. So finally we got 81 into 3 pi by 4. 3 pi by 4. So here we can knock down the final value. So 81 into 3 is 243 into 5 by 4. That is the final answer when you are integrating the integral. So we have to convert x and y all terms in terms of t, and we can substitute the limits of t. Then we can simplify to integrate the function. So this is the way to calculate the work done or integral value by using the line integral for the parametric values. See the next problem. Now, if f equal to 5xy minus 6x square into I plus 2y minus 4x into j. Here we have to evaluate the integral over c f bar dot dr bar along the curve c in xy plane. That xy plane, that is y equal to, that curve is y equal to x cube from 1 comma 1 to 2 comma 8. 1 comma 1 to 2 comma 8. So first we are going to write the solution. Solution is given f equal to 5xy minus 6x square into I plus 2y minus 4x into j. So what they given along the curve, that curve is y equal to x cube. So y equal to x cube, I can write dy. So dy, here we have to remember along the curve means we can do with respect to x, we can do with respect to y, or we can do with respect to t. Only one single value. So that's why if you are having any y terms, you can convert into x. Otherwise, if you have any x terms, you can convert into y. Otherwise, x and y both should be converted into t. So then only we can integrate the single integral or line integral. So that's why here y equal to x cube, I am converting this x in terms of y, then we can write. So dy, derivative of y is dy equal to 3x square, 3x square into dx, 3x square into dx. Now we are going to replace here. First f bar is x into y value is x cube. So f bar equal to 5xy minus 6x square into I minus 2y minus 4x into j. So in place of x, x is there. In place of y, x cube is there. So finally this is 5x power 4 minus 6x square into I plus 2 here, 2y is there. So in place of y, we replaced x cube. So 2x cube minus 4x into j. So that means we are replacing y equal to x cube value. So and we know integral f bar dot dr bar we need, right? So what is the dr bar? So dr bar equal to, if they given any r, then we can write this dr bar. So if they didn't given any r, we have to remember dr equal to dxi plus dyj. Two components is there. You can use two components. Otherwise, you can use the third component also based on the given problem. So here dr bar equal to dx into I plus dy into j. So this one dx value is as it is. So dy is at 3x square dx. We are replacing here 3x square into dx. So dr is finally dxi plus 3x square into dx into j. So f bar dot dr bar equal to, here f is 5x power 4 minus 6x square into I plus 2x cube minus 4x into j. Now dr bar is dxi plus 3x square into dx into j. This is the value of f bar dot dr bar. If you know this, we can integrate function now according to the given points. Now this value is 5x power 4 minus 6x square into dx plus 2x cube. This one is 5x power 4 minus 6x square into dx plus 2x cube minus 4x into 3x cube into dx. Now we are simplifying this one. 5x power 4. This is also dx, this is also dx. We can take the common here. 5x power 4 minus 6x square plus 2x cube minus 4x into, here for this term we are having the 3x cube for dx. So finally 5x power 4 minus 6x square. Here we are multiplying with 3 2s are 6. So 6x cube into x is x power 6. Next, here minus 12 into x power 4. When you are simplifying this, we are getting here 6x power 5. Next one is minus 5x power 4 minus 12x cube minus 6x square. That is only we simplify here. So now we got here 6x power 5 plus 5x power 4 minus 12x cube minus 6x square. So now we are doing the integration. So now integral 6 is the constant. So 6x power 5 plus 5x power 4 minus 12x cube minus 6x square. So this is integral. It will over curve C. So that curve is y equal to x cube. That curve is y equal to x cube. That is into dx. So here x limits are, what are the x limits? First of all, what is the given points? Given points are 1, 1 to 2, 8. Here these are the x and these are the y, and this is the x and this is the y. Now x limits are 1 to 2. X limits are 1 to 2 and y limits are 1 to 8. Y limits are 1 to 8. Here in the line integral we can do with respect to dx or with respect to dy. So if you are doing with respect to dx, x limits are 1 to 2. If you are doing with respect to dy, y limits are 1 to 8. So based on your calculation or based on your conversion, you can use the x and y limits. Here I got the terms all in terms of x. That means I am using the x limits. X limits are 1 to 2. So 1 to 2 into 6 into x power 5 plus 5 into x power 4 minus 12 into x cube minus 6 into x square dx. Now we are integrating the function here. 6 is the constant. Integral x power 5, that is x power 6 by 6. Limits are 1 to 2 plus 5 into integral x power 4, that is x power 5 by 5. Limits are 1 to 2 minus 12 into integral x cube, that is x power 4 by 4. Limits are 1 to 2 minus 6 into integral x square, that is x cube by 3. Limits are 1 to 2. This is only we are substituting here. So 6 will be cancelled. So 2 power 6 minus 1 power 6. Here 5 will be cancelled. Plus 5 into 2 power 5 minus 1 power 5. Minus here 4 3s are 12. Minus 3 into 2 power 4 minus 1 power 4. Here 3 2s are 6. So minus 2 into 2 cube minus 1. So now finally 2 power 6. 2 power 6 is 2 to the 4, 8, 16, 32, 64. So 64 minus 1 plus 5 into here. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So this value is 32. So here 64, here 32 minus 1. Minus 3 into 2 power 4. 2 to the 4, 4 to the 8, 8 to the 16. So 16 minus 1. Minus 2 into 8 minus 1. So finally, this value is 64 minus 1 is 63. Plus 5 into 32 minus 1 is 31. Here 5 is cancelled, right? There is no 5. So finally this is 31. Next, minus 3 into 2 power 4. So 2 power 4 value how much? 2 power 4 2 2s are 4 4 2s are 8 8 2s are 16. So 16 minus 1 is 15. 3 into 15 minus 2 into 2 cube, that is 8 minus 1 is 7. So now finally 63 plus 31 minus 15 is 45 minus 40. So finally we got the 35. So this value is equal to 35. This is the final answer. So this is the way we can calculate the given work done by using the given data. Is it clear? Now see the next problem. Find the work done by the force F equal to Zi plus Xc plus Yk when it moves the particle along the curve that R equal to cos t into I plus sin t into j minus t into k. The limits are here 0 to 2 pi. So here given F is Zi Xc plus Yk. We are taking the arc R equal to cos t into I plus sin t into j minus tk. So this is only we discussed here. So by using these two, we are calculating here the value. So integral 0 to 2 pi f bar dot dr bar. So f bar is nothing but here. What is the f bar? Zi plus xj plus yk plus xj plus yk dot dr bar is nothing but dxi, dyj and dzk. So when you're comparing the x and y values we got here. So this is minus sin t into I minus cos t into j minus k. So after doing the f bar dot dr bar, so here f bar is the given value. So zi. So z. So what is the z value here? Minus t. So here zi means minus t into I. Next xj. Xj means here cos t. So cos t into j. Y is sin t. So sin t into k into dr bar. So what is the dr bar? We are replacing here minus sin t into I plus cos t into j minus k into dt. So finally minus t into sin t. I dot I is 1. So t sin t plus cos t into cos t. This is cos square t minus here sin t. So here there is no quotient of k here. So sin t into t. This term will be 0. Now we got t sin t plus cos square t minus sin t. Now we are substituting here integral. T limits are 0 to 2 pi. Integral 0 to 2 pi t sin t into dt and minus and minus. Plus here there is no term here. So integral plus integral 0 to 2 pi cos square t minus integral 0 to 2 pi sin t dt into k. So now we are doing here t into. So this term how we got here. So you can observe we can use u into v. So what is the u? U v dash minus. So what is the derivative of u into v? U v dash minus integral dv and whole d. Now by using this formula we are doing here. So 2 into dash is minus integral v dv value is. So t into minus cos t 0 to 2 pi. Here p1 is integral minus sin t 0 to 2 pi into dt. Now integral cos 2t I am writing as 1 plus cos 2t by 2 and here minus integral sin t dt. So now when you are subtracting the limits here we got minus 2 pi and here this is the cos t limits are 0 to 2 pi 1 by 2 into here 1 by 2 is the constant integral dt is t and integral sin t is sin 2t by t and here integral sin t is cos 2t. So when you are subtracting the limits here this is the 2 pi 1 minus 1 we got here cos n pi 1 by 2 into here this one is 2 pi. So minus 1 is 0. So finally these two will be cancelled. So minus 2 pi plus pi. This is finally minus 5. This is the final answer. So this is the way we can calculate the given problem by using the given data. So line integral work done is the main important application for that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.